on section 2.1, which is finding average rate of change and instantaneous rate of change from a function. So our first question is, what is the average rate of change of f of x? I want you to get very used to, in your brain, you see average rate of change, but your brain says slope. Okay, and then we have an interval here. Remember, for an interval, these are x coordinates. So the beginning of our interval that we want the average rate of change is going to be x equals 4, and the end is going to be x equals 9. So if I want to find the slope, I need to figure out y coordinates. One of my ordered pairs would be 4, comma. If I plug in 4 here, I get 1 over square root of 4, which is 1. And if I plug in 9, I get 9, comma, 1/3. So one way you can think of it is y2 minus y1 over x2 minus x1. The other way you can think of it is that difference quotient, f of 9 minus f of 4 over 9 minus 4. Okay, so that's going to be 1/3 minus 1/2 over 5. And then we need a common denominator, so we can say that's 2/6 minus 3/6 over 5, or negative 1/6 over 5, or because of copy dot flop, if you had teachers who taught you that, or because the dividing is the same as multiplying by the reciprocal, we have negative 1/30th, and that is our average rate of change on that interval. The instantaneous rate of change is still the difference quotient, but it's the limit of the difference quotient as our 2 points get super close together. So our 2 points are 4, comma 1/2, because that's x equals 4, and the other point is just a little tiny distance away, 4 plus h over 1 over square root of 4 plus h. There is a temptation, I'm sure, to take the square root of 4 and say, oh, that's the same thing as 1 over 2 plus h. Stop yourself, because square roots don't work that way. You can't take a square root over addition like that. So those are our 2 points. If I think of it as the difference quotient, it's going to be the limit as h goes to 0 of f of 4 plus h minus f of 4 all over 4 minus h, which 4 plus h minus 4, which is h. Now we do some evaluations. So we have the limit as h goes to 0 of 1 over root 4 plus h minus 1/2 h. All right, I see a fraction, and my first thought with fractions is common denominator. My other thing is that this is a limit, so let's try plugging in 0. If I plug in 0, I get 1 over square root of 4 plus 0, which is 1/2, minus 1/2, which would be 0 over 0. So we can't just plug in, we have to do more work. So I'm going to find the common denominator here. And then I'm going to subtract, because I can, because I have a common denominator. Minus root 4 plus h over 2 plus h. And instead of writing all over h like I have been, I'm going to say times 1 over h, multiplying by the reciprocal. Okay. Now plugging in 0 for h still leaves us with that 0 over 0 indeterminate form. So we still have to do more, but that's a good starting place. What I see is kind of, this is crying out for a conjugate pair. So that's going to be my next step. I'm going to multiply by the conjugate pair, 2 plus 4 plus h, which I'm allowed to do as long as I do it to the denominator as well, because that's just multiplying by 1. So then I rewrite this a little bit. I'm ignoring this 1 because multiplying by 1 doesn't do anything. So then I have 4. I get to drop out my common term, my middle terms, because this would be negative 2 root 4 plus h, and this would be positive 2 root 4 plus h. But my last term would be square root of 4 plus h times square root of 4 plus h, which would just be 4 plus h. Now, in my denominator, I am not going to do simplifying. I'm just going to rewrite stuff, because simplifying for simplifying's sake is going to make you crazy. Also, it actually makes it much harder to see what cancels. So don't go distributing that denominator until you have no other options. Okay, what I notice is that these 4s are going to subtract away, and that in the numerator, I'm left with just negative h. See why it's negative h? Distribute this guy. In the numerator, I have negative h. In the denominator, I have a whole bunch of junk. But now, the numerator is a string of multiplication. 2 times h times that, which means that I can cancel my h's here, because they divide to make 1. And now, when I plug in 0 for h, I don't have a big ugly mess. I have a numerical answer. I have negative 1. I have 2 times the square root of 4 times 2 plus the square root of 4. Square root of 4 is 2. That would be 2 times 2 times 4. So that would be 16. So negative 1 over 16. That is the slope at the point x equals 4. That is the instantaneous rate of change for that function. You might be saying, oh my goodness, Miss Gall, that's a lot of limits. That's a lot of work. Yeah, I wonder if there's a better way. There might be a shortcut. So